The numbers do not lie. 2,144 aftershocks in 72 hours. 8 Mexican states are registering systematic geological responses. 90 millimeters per year of relentless Cocos Plate subduction beneath 20 million residents. What seismologists discovered after the January 2nd magnitude 6.5 Guerrero earthquake shattered fundamental assumptions about Mexican geology. This was not an isolated rupture, it was a systematic network activation spanning 2,750 kilometers of interconnected fault systems. Mexico's subduction zone had just demonstrated its ability to coordinate stress transfer across 8 states simultaneously. From the rupture point near San Marcos to amplified shaking in Mexico City, 300 kilometers away, the geological response followed patterns that proved Mexico's fault network operates as a single, continent-spanning system. The breakthrough came from analyzing stress propagation data. The Cocos Plate subducting at the fastest rate on Earth does not create isolated earthquakes. It generates systematic network failures that can activate multiple states in coordinated sequence. Recent tectonic research had predicted this possibility, but the Guerrero earthquake provided the first real-time proof. Mexico's geological network responds to single ruptures with multi-state activation patterns that can overwhelm emergency response capacity across an entire nation. Here is what is terrifying researchers. The Guerrero segment has been accumulating strain for 115 years without a major release since 1911. If a magnitude 6.5 earthquake can coordinate 8 state responses, what happens when over a century of stored pressure finds its systematic release across Mexico's interconnected fault network? Seismologists are quietly recalculating earthquake probabilities for scenarios involving simultaneous multi-state collapse. The data suggests Mexico's next great earthquake will not be localized, it will be systematic. The Guerrero magnitude 6.5 revealed that Mexico does not host isolated earthquakes. It operates a continental-scale geological network that could coordinate simultaneous disasters across 8 states, affecting 20 million people in coordinated collapse scenarios that emergency systems are not designed to handle. In 1978, seismologists identified something terrifying along Mexico's Pacific coast. The Guerrero segment, a 200-kilometer stretch of the Middle America Trench, had gone suspiciously quiet. While neighboring regions regularly released geological pressure through devastating earthquakes, Guerrero remained ominously silent. Dr. Gerardo Suarez's research team at UNAM discovered that the Guerrero seismic gap had not experienced a major thrust earthquake since March 1911. Every other segment of Mexico's subduction zone had ruptured multiple times. Mecocan in 1985, magnitude 8. Oaxaca in 1968, magnitude 7.1, and again in 1978, magnitude 7.8. Colima in 1995, magnitude 8. But Guerrero, nothing. The gap wasn't dormant, it was loading. Tectonic stress has been accumulating for over a century without release. Between 1998 and 2026, GPS monitoring revealed Guerrero's hidden secret. Every 4 years, the locked fault interface would silently release pressure through slow slip events. These are geological movements lasting months instead of seconds, equivalent to magnitude 7 or greater earthquakes, but completely aseismic. Dr. Vladimir Kostoglodov's team discovered that these slow slip events were systematically interacting with earthquakes. The 2014 Papineau magnitude 7.3 earthquake occurred exactly during an active slow slip event. It was the first real-time proof that slow slip could trigger devastating ruptures. Precise seismic imaging revealed why Guerrero behaves differently. The Cocos Plate beneath Guerrero follows an unusual flat slab geometry, diving at shallow 15-degree angles to 40 kilometers depth, then flattening to a nearly horizontal trajectory that extends 200 kilometers inland. This geometry creates maximum stress concentration over the largest possible area, a fault interface that is 200 by 100 kilometers, storing decades of unreleased energy. Critical measurements show a convergence rate of 70 to 90 millimeters per year, a slab depth of 40 to 50 kilometers, and an interface coupling of 85%, locked between slow slip events. The 2017 to 2019 earthquake sequence proved Guerrero's connections to regional networks. The magnitude 8.2 Tehuantepec earthquake in September 2017 triggered slow slip events in both Guerrero and Oaxaca, which then influenced the magnitude 7.1 Puebla Morelos earthquake 12 days later. Dr. Victor Cruz Atienza's analysis showed these were not coincidences. They were systematic stress transfer cascades across 650 kilometers of interconnected fault systems. The Cocos Plate operates as a unified stress network, not isolated segments. 23 million years ago, the ancient Farallon Plate shattered, creating today's Cocos Plate, a 2.86 million square kilometers slab of oceanic crust, diving beneath Mexico at 90 millimeters per year. This is not ordinary subduction. It is systematic continental destruction. The process works like a massive geological conveyor belt. Dense oceanic crust plunges beneath lighter continental crust, dragging the North American plate downward and building enormous elastic strain. When stress exceeds rock strength, the continental plate snaps back violently, releasing decades of stored energy in seconds. But here is what makes Mexico's system uniquely dangerous. The subducting slab's young age, 0 to 25 million years, keeps it hot and buoyant, creating shallow subduction angles that maximize contact area with the overriding plate. More contact equals more coupling. More coupling equals larger earthquakes. This combination is dangerous for densely populated coastal regions. The Guerrero segment represents the most dangerous configuration. Young, hot oceanic crust subducting at an optimal depth beneath 20 million residents, with 115 years of unreleased strain and proven ability to coordinate responses across 8 states. Guerrero concentrates stress in a way that can drive multi-state ruptures with far-reaching consequences. September 19, 1985, 7:17 a.m. The Michoacan segment, immediately northwest of Guerrero, released 84 years of accumulated strain in a magnitude 8.0 rupture. The earthquake killed between 5,000 and 45,000 people, collapsed 412 buildings, and proved that Mexico's subduction zone could destroy the nation's capital from 400 kilometers away. The 1985 disaster revealed Mexico City's Achilles heel, ancient Lake Texcoco sediments that amplify distant earthquakes by factors of 5 to 10. Seismic waves that barely register in solid rock become building-toppling monsters in Mexico City's soft lakebed foundation. The terrifying parallel, Guerrero sits 300 kilometers from Mexico City, closer than Michoacan, with 115 years of strain, versus Michoacan's 84 years in 1985. The accumulated energy beneath Guerrero could produce a magnitude 8.5 or greater earthquake, with even more devastating amplification in Mexico City. Today's Mexico faces an exponentially greater risk than it did in 1985. Mexico City's population has grown from 14 million to 22 million. Vertical development has created thousands of resonant frequency buildings. Critical infrastructure, airports, hospitals, and government centers sit directly on the ancient lakebed. To understand Guerrero's accumulated strain, consider the numbers. The 2011 Tohoku magnitude 9.0 earthquake released energy equivalent to 600 million tons of TNT. But that earthquake released only 1,000 years of plate motion in a mature subduction zone. Guerrero's 115 years of unreleased strain at 90 millimeters per year convergence represents 10 meters or more of potential slip across a 20,000 square kilometer fault interface. The energy calculation is equivalent to 200 to 400 million tons of TNT concentrated beneath Mexico's most populous regions. The Cocos Plate beneath Guerrero isn't just another earthquake threat, it's a continental-scale energy storage system that could release over a century of accumulated strain in a systematic disaster affecting 1/4 of Mexico's population. The January 2nd Guerrero earthquake revealed something seismologists had theorized but never observed. Mexico's geological network can coordinate disasters across 8 states simultaneously. When the next great Guerrero earthquake strikes, it won't just affect local areas, it will trigger systematic responses from Jalisco to Veracruz. In the primary impact zone of a magnitude 8.5 plus scenario, Guerrero would face complete infrastructure collapse within 100 kilometers of the rupture. Mecocan would experience severe shaking, port facility damage, and agricultural disruption. Morelos would see building collapses in soft soil areas and tourist zone destruction. And in Mexico City, 1985-style amplification, but 3 times more severe. The secondary Cascade zone would be just as devastating. Oaxaca would suffer triggered slow slip events and secondary earthquake sequences. Puebla would face industrial facility damage and transportation corridor disruption. Veracruz, with its critical port infrastructure and oil refineries, sits directly in the vulnerability zone. Even Jalisco, home to Guadalajara, could see high-rise damage hundreds of kilometers from the epicenter. The systematic pattern is clear. A single great earthquake in Guerrero could trigger coordinated infrastructure failures across 1/3 of Mexican territory, affecting 45 million residents and 60% of Mexico's economic capacity. Mexico's utility networks were never designed for 8-state systematic failures. The January 2nd earthquake's 29 gas leaks and multi-state power outages provide a blueprint for a catastrophic infrastructure cascade. Mexico's power grid depends on centralized generation and transmission across geological fault networks. Major power plants in Guerrero, transmission lines crossing active fault zones, and distribution networks built on soft soils create systematic failure points. A great Guerrero earthquake would trigger immediate power loss across 8 states, leaving 45 million without electricity as transmission lines fail and transformer stations collapse. Modern Mexico depends on cellular towers, fiber optic cables, and data centers concentrated in earthquake-vulnerable zones. The systematic failure pattern would be devastating. Cell towers could collapse in the primary impact zone, fiber optics could be severed along routes that cross faults, internet exchange points could fail in Mexico City, and satellite backup systems would be overwhelmed by simultaneous demand. Mexico's economy depends on transportation corridors that cross directly over active fault systems. Highway bridges span fault zones, rail lines connect Mexico City to Pacific ports, airport runways sit on soft soil amplification zones, and port facilities are vulnerable to liquefaction and tsunamis. Mexico City generates 23% of Mexico's GDP while sitting directly in Guerrero earthquake amplification zones. A great Guerrero earthquake would not just damage buildings, it would trigger systematic economic collapse across North America. The financial system cascade is chilling. Banking headquarters are located in Mexico City's earthquake amplification zone. The stock exchange is housed in soft soil buildings that are vulnerable to resonance collapse. Government operations sit on the ancient lakebed, and critical Pacific port facilities are in direct impact zones. Economic modelling suggests a great Guerrero earthquake could trigger $200 to $400 billion in direct damage, which is 3 to 6% of Mexican GDP. It could require a 12 to 18-month reconstruction timeline, disrupt North American supply chains, and cause a regional recession extending to the United States and Canada. Following the January 2nd earthquake and its 8-state systematic response, Mexico's National Seismological Service is deploying UN-precedented monitoring technology across the Cocos Plate network. Dr. Scioli Perez Campos directs a real-time geodetic array spanning 2,750 kilometers of subduction interface, the most comprehensive earthquake monitoring system ever constructed. 500 plus GPS stations track millimeter-scale plate movements ocean bottom seismometers monitor offshore rupture zones. Slow slip events are detected within 48 to 72 hours of initiation, and 8 state coordination protocols guide systematic emergency response. Mexico is racing to get ahead of the next great quake. Dr. Perez Campos says we can now detect when the Cocos Plate begins systematic stress transfer. The question is not whether we will detect the next great earthquake preparation, but whether detection provides enough time for systematic evacuation and across 8 states simultaneously. Despite advanced monitoring, fundamental uncertainties remain about Mexico's geological network behavior. The January 2nd earthquake revealed systematic coordination patterns that earthquake science can describe but not precisely predict. Guerrero's fault network has demonstrated coordinated behavior with 115 years of unreleased strain accumulation, 90 mm per year continuous stress loading, 4-year slow slip cycles creating elevated risk windows, and an 8-state systematic response capability confirmed. But the exact rupture timing within the 30-year probability window, the magnitude potential in the magnitude 8.5 to 9.0 range, the infrastructure cascade severity during systematic multi-state failure, and the international response capacity for disasters exceeding regional emergency systems all remain unknown variables. Dr. Vladimir Kostoglodov's latest analysis confirms the systematic threat. He says Guerrero's fault network has demonstrated coordinated behavior, and we understand the mechanics, but the triggering process involves too many variables for precise prediction. The January 2nd Guerrero earthquake transformed earthquake preparedness from local to systematic planning. Mexico no longer faces isolated earthquake threats. It confronts continental-scale network disasters that could overwhelm an entire nation. Systematic preparedness now requires 8-state evacuation coordination protocols, infrastructure redundancy across geological networks, international aid agreements for disasters exceeding regional capacity, and economic continuity, planning for supply chain disruption. The stakes extend beyond Mexico. North American economic integration means that Mexican systemic collapse triggers an international recession. Pacific trade routes, manufacturing supply chains, and energy distribution networks all depend on infrastructure crossing Mexico's active geological networks. Mexico's Cocos Plate network has accumulated 115 years of systematic stress while demonstrating coordinated 8-state response capability. The geological evidence is clear. Mexico faces an inevitable systematic disaster within decades, not centuries. As Dr. Suarez concludes, the Guerrero earthquake revealed Mexico's geological reality. We do not host isolated earthquakes. We operate continental networks that can coordinate simultaneous disasters. The only question is whether we prepare for systematic collapse or wait for it to overwhelm us. Earth Attacks explores the hidden networks that could reshape civilization itself. What systematic threats has your region been quietly accumulating? Are your emergency systems ready for coordinated disasters that exceed local response capacity? Let us know in the comments. Subscribe to stay ahead of the geological forces operating beneath our feet, because the next systematic disaster might not provide any warning at all. When the big one strikes, Earth Attacks will be there on the front lines of the fracture.